It's a busy, freezing cold day inside the National Ice Core Lab in Denver, Colorado.
We're going to cut gas samples out of this core.
Scientists from Maine to California here to cut pieces of precious Antarctic glacier ice to take back to their labs for study.
We started the Ice Core project in 2005.
With support from the National Science Foundation for a project called the West Antarctic Ice Sheet, or WAIS Divide, lab manager Mark Twickler and a team of scientists, engineers, and support personnel traveled to the bottom of the world to drill out and bring back these ice cores. The goal of the project? To collect and study perfectly preserved records of the distant past.
The unique things about polar glaciers is each year that it snows there, the snow never melts. So you get 1 year of snow on top of the next year's snow. It compresses, so everything that fell out of the atmosphere, dust, salt from the ocean, volcanic ash, is preserved in that ice core.
This particular ice sheet is more than 70,000 years old. The team drilled down more than 2 miles into it to retrieve these cores, which were then flown to the U.S. and stored in a giant 40 below zero freezer here at the Ice Core Lab.
Inside this freezer contains more than 10 miles of ice cores collected from around the world.
Twickler says the ice core's layers are like tree rings, each layer representing a year of weather and snow.
We can tell what the temperatures were. We can tell how rough the oceans were around Antarctica. We can tell how dusty Australia was.
Scientists are keen to study the bubbles trapped in the cores, each a tiny pocket of air frozen in time.
We can measure a variety of gases that were in the atmosphere at the time the bubbles were formed.
Other scientists want to know how ice sheets melt over time.
We don't necessarily have a really good handle on how the ice sheet as a whole will respond in a case of changing climate.
Twickler says this icy blast from the past is helping researchers better understand the mechanics of climate change, and that in turn will help them make better predictions as to what a changing climate may mean for our future. For Science Nation, I'm Miles O'Brien.
This is our drilling shelter. It's a steel arch building, and inside of it, of course, we have the drill. The drill's laid out horizontally right now. It's actually a one-of-a-kind drilling tool. It's unlike any kind of water well or oil well drill. It's actually much more of a scientific instrument than a piece of drilling machinery. The business end of it is right down here. It has 4 razor-sharp cutters. The drill is moved up into a vertical position and then lowered down into the ice sheet. This drilling head then rotates around, and these cutters shave off a ring of ice. The drill slips down into that ring of ice, and the core slides up into the core barrel. We then pull up on the core barrel, and there are little latches in here that catch the core, and we bring the core up to the surface.
To research Earth's climate history, scientists who study ice cores work hand in hand with engineers to design a range of tools that meet their specific needs. One example of this collaboration can be seen in the design and development of ice core drills. Let's catch up with Jay Johnson and Tanner Kuhl, 2 engineers from the University of Wisconsin's Ice Drilling Design and Operations Group, as they test the newly designed Blue Ice Drill.
This is what we're calling the Blue Ice Drill. You see here, it's a fairly standard double barrel ice coring drill.
This drill is specifically designed to take a 9.5-inch ice core, which is much larger than most of the drill systems use. And it's because of the demand by the scientists that they needed large quantities and large volumes of ice.
Down at the bottom we have a core head that has 3 cutters. The core head spins around and the cutters shave the ice and then transport the chips up the flights of the barrel between the 2 barrel sections. The inner barrel spins, the outer barrel stays stationary, and it's that difference that actually drives the chips to the top and gets them out of the hole so that we can then take the core. What we're going to do now, we're going to use the winch to lower the drill down.
In order to keep this drill from spinning in the hole, because this is just a swiveling rope connection here, we have to put a handle on the top of this, and then one person holds that, and that counteracts the cutting action. So I'll be doing the anti-torque of the drill. Tanner will be lowering it and doing the feeding. So the switches here are built right into the handles of this anti-torque car. Here, we'll start it up. All right, stop there.
Yep. All right, so now that we've drilled the core and sitting down there on the bottom of the hole, it's still one solid column of ice that's connected to the ice below it. So we need to break that ice. To do that, we use this winch to pull up to 6,000 pounds. And in the coring head of the drill are 6 spring-loaded sharpened steel teeth that will spring in and bite the core, send a crack all the way across the top, breaking it off from the ice beneath it, and then they'll capture it and hold it in the drill so that we can pull it up with the winch and bring it to the surface.
So now we're going to separate the barrel so we'll be able to see the core and the chips come out of it. We're going to do our reverse spin on the barrel just to clean some of these ice chips out. Now the inner barrel is free, and we can lift the drill up and take the core barrel away. So now we'll lay this barrel down and pull the chips out and remove the core. Our plug that separates the chips from the core is connected by a string here. These are the ice chips that we just drilled or created with the cutting process. I'm just going to give the core a little bit of a push to disengage it from the core dogs here. And now it's free, and I'll just tip the barrel up, and I'll see it come out the other end. So there's a nice little core we just drilled. If this were the actual in the field and using this for science, this would have been pushed out into a tray and saved. We'd be a little bit more gentle with it, but for testing here, we're just pushing it out on top of the existing ice chips. So.
Based on the results from the testing phase, Jay and Tanner will go back to their offices to redesign and optimize the drill before sending it to the field. The Blue Ice Drill's large diameter cores enable scientists to gather adequate volumes of trace methane gases and rare carbon dioxide isotopes to answer how and why these climate indicators have varied in the past. This drill is one example of how engineers, responding to scientists' research goals and constraints, can build designs that further our understanding of our world.
The drill work area is just a little below freezing, but to keep the gas samples trapped in the ice, we have to keep the temperature of the ice core below -20°C. It's on the other side of the window, where the core is pushed out of the drill. It's always cold. We even have a large refrigeration system to make sure it stays cold.